Two robots, two countries, two completely different philosophies about the future of humanoid machines. Unitree keeps shipping thousands of robots while everyone else is still making promises. While Tesla has revealed Optimus Gen 3 with promises that will change everything we know about automation, one bets everything on AI and scale. The other bets on what you can actually buy today. This is the real showdown. The future of robotics will not be decided by hype or viral demos. It will be determined by which humanoid robot can actually walk into human spaces and work. Tesla is building Optimus Gen 3, a full-scale machine designed for mass production, long-term autonomy, and AI-first learning. Unitree is shipping the G1 and H2 compact humanoids focused on accessibility, real-world deployment, and getting hardware into the hands of developers right now. Instead of brand loyalty or speculation, we are examining what truly separates these machines: specifications, maturity, AI philosophy, hardware design, and realistic use cases. The question is deceptively simple. Which humanoid robot is actually leading the race? Size and weight define everything in humanoid robotics. Balance Stability Actuator demands payload capacity and cost all flow from physical form. Tesla Optimus Gen 3 stands at roughly 1.73 meters tall, placing it squarely within adult human proportions. Weighing around 55 to 57 kilograms, it is engineered to function as a full-scale labor machine designed to operate in environments originally built for humans. Doorways, workstations, factory aisles. Optimus is meant to move through them naturally. Its design language is unmistakably Tesla's smooth surfaces, minimal visual complexity, and a form factor that feels closer to consumer electronics than traditional industrial robotics. Unitree's G1, by contrast, is intentionally compact. Standing around 1.3 meters tall and weighing roughly 35 kilograms with battery, G1 feels more like an adolescent-sized humanoid. This smaller scale is not a limitation, it is a strategic decision. A lighter robot demands less torque, less power, less structural reinforcement, and significantly lower hardware cost. It is easier to transport, easier to recover from falls, and easier to integrate into lab environments. Where Optimus is designed to fit into the human workforce, G1 is designed to fit into the research ecosystem. Unitree's newer H2 model stands taller at 1.8 meters, bridging the gap between G1's compactness and Optimus Gen 3 full human scale while maintaining agility advantages. Movement is where humanoid robots reveal their true engineering depth. Tesla claims Optimus Gen 3 incorporates major improvements over Gen 2, with enhanced walking speed estimated around 2.5 meters per second and significantly improved stability. Optimus is not trying to win sprinting contests. It is trying to work all day without wasting energy. Tesla's actuator strategy prioritizes efficiency and integration. Every joint is powered by Tesla-designed electric actuators, combining motors, gearing, and sensing into tightly optimized units. The emphasis is clear durability, cost optimization, and industrial reliability. Unitree G1's movement philosophy is different. Thanks to permanent magnet, synchronous motors, and configurations offering up to 43 degrees of freedom, G1 showcases fluid, highly articulated motion. Its smaller mass allows surprisingly agile walking and natural-looking body dynamics. But the real advantage lies in articulation density. Extra waist freedom, wrist flexibility, and optional dexterous hands give G1 a level of expressive movement that researchers love. Unitree's H2 takes this further, demonstrating parkour capabilities. Aerial flips exceeding 3 meters and cluster coordination at speeds reaching 4 meters per second during live demonstrations. It is less about brute strength and more about motion versatility. Optimus moves like a worker. G1 and H2 move like platforms for experimentation and dynamic performance. Battery design quietly defines a robot's usefulness. Tesla Optimus Gen 3 is powered by an enhanced battery pack estimated around 2.3 kilowatt-hours. Tesla frequently describes this as enabling all-day operation, though realistic expectations vary depending on workload, duty, cycle, and task intensity. Heavy lifting drains faster. Light inspection lasts longer. Tesla's goal is clear industrial endurance without frequent charging interruptions. Unitree G1 operates in a different regime, with its 9,000 mAh quick-release smart battery runtime typically sits around 2 hours. That sounds modest, and for continuous factory labor, it would be. But G1's battery is swappable. This changes the equation entirely. Instead of waiting for recharge cycles, operators can simply replace the battery and continue operation. For labs, demos, and research sessions, this flexibility often outweighs raw endurance. Tesla optimizes for long shifts. Unitree optimizes for modular workflow and rapid iteration. The philosophical divide becomes dramatic when examining sensors and perception. Tesla Optimus Gen 3 adopts Tesla's signature camera-only perception strategy. No LiDAR, no depth scanning towers, just vision. Multiple cameras feed neural networks adapted from Tesla's full self-driving stack. These networks perform pose estimation, object recognition, navigation, and environmental understanding. Tesla's belief is bold vision plus large-scale neural learning will outperform expensive sensor redundancy. Advantages include lower hardware cost, fewer components, and continuous improvement through AI training. But this approach also carries risk. Vision-only systems struggle in edge cases, poor lighting, reflective surfaces, occlusions. Unitree G1 embraces a more classical robotic stack. LiDAR for precise spatial mapping, depth cameras for structured perception, IMUs for motion awareness. This sensor fusion approach is extremely attractive for research because it supports SLAM reproducible experiments and direct control pipelines within ROS ecosystems. Tesla bets on data scale. Unitree bets on sensor precision and immediate reliability. Tesla Optimus Gen 3 is powered by Tesla's proprietary AI infrastructure. Training draws from teleoperation, human demonstrations, factory data, and Tesla's vast vehicle fleet vision priors. The robot benefits from Tesla's Dojo supercomputing ambitions and neural network expertise. But Optimus is closed. There is no public SDK, no ROS access, no developer kit. External engineers cannot simply purchase Optimus and experiment freely. Tesla controls the entire development stack from hardware to software. Unitree G1 is almost the opposite. Built around high-performance CPUs and often NVIDIA Jetson Orin modules, G1 is designed for developers. ROS and ROS2 support allow researchers to access perception control and behavior layers directly. This openness has enormous implications. Students learn on G1, researchers publish on G1. Developers prototype on G1. An entire ecosystem has formed around Unitree platforms because the company shares rather than restricts. Tesla controls the stack. Unitree shares the platform. Dexterity and manipulation separate theoretical capability from practical utility. Tesla Optimus Gen 3 features hands with enhanced degrees of freedom and improved tactile sensing over Gen 2. Demonstrations show delicate handling, small object sorting, and human-like grasping behavior. Payload estimates, around 20 kilograms, place Optimus in real labor territory. It can lift boxes, carry parts, and handle industrial materials safely and repeatedly. Unitree G1's payload is far more modest, typically around 2 to 3 kilograms per arm, but its optional dexterous hands, hybrid force, position control, and high articulation make it ideal for manipulation research. It may not lift heavy loads, but it excels at experimentation involving grasping teleoperation and learning algorithms. Recent demonstrations showed G1 and H2 models handling martial arts weapons, including staffs, nunchaku, and swords with precision during live performances. Optimus is built to work. G1 and H2 are built to explore possibilities and push dynamic limits. Pricing and market access is where theory meets economics. Tesla's Optimus Gen 3 is not commercially available yet. Tesla's long-term price target, often cited between $20,000 and $30,000, is potentially revolutionary. If achieved, it would redefine humanoid affordability and enable mass deployment. But as of early 2026, this remains a promise without confirmed delivery timeline or external validation. Unitree G1 is real and shipping now. Base configurations begin around $13,500 to $16,000, with higher EDU variants scaling upward depending on compute degrees of freedom and accessories. For anyone needing a humanoid robot today, G1 is one of the most accessible entry points globally. Unitree reported over 5,500 humanoid units shipped in 2025, ranking first worldwide in commercial humanoid shipments. Maturity and deployment reveal which platform delivers beyond promises. Tesla Optimus Gen 3 operates inside Tesla factories, performing controlled internal tasks. This provides valuable real-world data, but limits external validation and independent assessment. The robots work in environments Tesla controls, completely optimized, specifically for Tesla's production needs.